Section 1.5, multiplying and dividing real numbers. Last time we looked at adding and subtracting. So let's be reminded of what it means to multiply. Multiplication indicates repeated addition. And so 3 times 2 means 2 plus 2 plus 2. 3 2s. Add them up. That's how we get to 6. So what would it mean if I multiplied 3 times negative 2? Well, 3 times negative 2 would be negative 2 plus negative 2 plus negative 2. Add those up, total of negative 6. What happens if I put a negative out in front? Negative 3 times 2. Well, we already know 3 times 2 is 6. This negative in front can be seen as floating. So that would give me negative, and 3 times 2 is 6. And if both numbers are negative, if we see this negative as floating out in front, then it will just travel into the next step unaltered. And so we have that negative out front. We already know that 3 times negative 2 is negative 6. And according to our double negative rule, in this situation, 2 negatives make a positive. So look at what we have here. 3 times 2 is 6 every time. And the sign on my answer? Well, if the two numbers I'm multiplying have the same sign, both positive or both negative, my answer will be positive. If my two numbers I'm multiplying are of opposite sign, my answer will be negative. Look at the blue box that we have on page 66. Multiplying numbers of different signs. It says for any positive real numbers x and y, the following hold. And those algebraic statements are simply saying what? That when you multiply two numbers of different signs, the answer will be negative. Likewise, here on page 67, blue box middle of the page, multiplying two negative numbers. If you multiply two negative numbers, you will get a positive. And then these are summarized for us at the bottom of page 67. Multiplying sign numbers. The product of two numbers with the same sign is positive. The product of two numbers with different signs is negative. Let's talk about division. And for division, let's use the results that we already have here on the board. Let me make a little room. Division is just reversing multiplication. If we look at this first problem, an equivalent division problem would be that 6 divided by 2 should give me back that 3. A division problem that would represent our second line here, our answer, negative 6 divided by that negative 2, would have to return us what? That positive 3. Reversing this one, negative 6 divided by that positive 2 should give us back negative 3. And finally, 6 divided by negative 2 will give me negative 3. And if we look closely at what's going on, we see that the rule for division is going to be the same as the rule for multiplication. That is, look at these top two. When I divide two numbers of the same sign, the answer will be positive. When I divide two numbers of opposite sign, the answer will be negative. And your book gives this to us on page 69 in the blue box, just above the center of the page. saying that the quotient of two numbers with the same sign is positive. The quotient of two numbers with different signs is negative. On the previous page, because I approached the topic a little differently than your book did, we do have a definition of division. You remember in the previous section, after looking at addition, we had a definition of subtraction, which was to add the opposite. On page 68, our blue box just below the center of the page defines division in terms of multiplication, saying that for any real numbers x and y, where y is not 0, the following holds. X divided by y equals x times 1 over y. 1 over y just indicates the reciprocal or the multiplicative inverse of a number, which is defined in the brown box center of the same page. Pairs of numbers whose products are 1 are reciprocals or multiplicative inverses of each other. In other words, if I have 2/3, its multiplicative inverse, its reciprocal, is 3/2. Why? Because when I multiply these together, their product is 1. Typically, we think of a reciprocal as taking a number like a fraction and flipping him over. The reciprocal of 4, well, that's 4 over 1. So its reciprocal would be 1/4. And when I multiply 4 times 1/4, I get 1. The product of reciprocals is 1. Our definition of division says that division can be defined in terms of multiplication, in that we can take the dividend times the reciprocal of the divisor. This is 2 over 1, flip it over, 1/2. The reciprocal of 2 is 1/2. When I multiply, we think of that 10 as being over 1. 2 goes into 10 5 times. My answer would be 5 over 1. We don't write over 1. And looking at this from start to finish, 10 divided by 2, which I could write as 10 times a half, 10 divided by 2 is 5, which we know to be true. Anytime you are multiplying, anytime you are dividing, you could always represent that in terms of multiplication using flip and multiply. Flip that second number over and change to multiplication. Now let's take a minute just to make sure that we've got this. Let me give you a number and ask you, what is its additive inverse or its opposite? That's from the previous section. And then I want to know, what is its multiplicative inverse or reciprocal from this section. So if I have the number 2/3, its additive inverse, we change the sign, and that's all we do. The additive inverse, negative 2/3. The multiplicative inverse, we flip it over. 2/3, its reciprocal is 3/2. If I have the number negative 4/5, its additive inverse, change the sign, is going to be positive 5/4. Its multiplicative inverse or reciprocal, I take the original number and just flip it over. It does not change the sign would remain the same. Did that completely backwards. Let's try that again. To find the additive inverse, we change the sign. And so the additive inverse of negative 4/5 would be positive 4/5. To find the multiplicative inverse, we flip it over. has nothing to do with changing the sign. So when we take the reciprocal of negative 4/5, we get negative 5/4. We can check that. Remember, reciprocals have to multiply together to give me positive 1. What is negative 4/5 times negative 5/4? Well, negative times a negative is positive. So this would give me positive 20/20ths if I don't cross cancel. And then, of course, that simplifies to positive 1. So that works. What is the additive inverse of 7? Negative 7. What is its reciprocal? Think of this as 7/1. And its reciprocal would be, just turn him over, 1/7. The additive inverse of negative 8. The additive inverse of negative 8 is positive 8. We change the sign. The multiplicative inverse has nothing to do with the sign. It has to do with flipping it over. So the sign remains the same. It would be negative. You flip an 8 over, you get 1/8. Let's turn to the homework set. Do a couple of these problems. When you multiply two numbers of the same sign, your answer is positive. When you multiply two numbers of opposite sign, your answer is negative. And so we've seen that already with the examples we used to build those ideas. Let's look at number 22. Not only are we dealing with sign numbers, but we have decimals as well. Multiplying decimals, do you remember how to do this? You do not line up the decimal points. We multiply them as though they are whole numbers. We ignore the decimal points for the moment. 4 times 6, 24, carry a 2. 16 makes 18. 2 times 6 is 12, carry a 1 is 9. Total of 1,104. But to figure out where the decimal goes in my answer, I will count the number of decimal places in the problem. 1, 2, 3 decimal places total in the problem, and so I will give 1, 2, 3 decimal places to the answer. So just the product is going to be 1.104, and the sign on my answer, a negative times a positive, is negative. Let's look at number 24. Not only are we dealing with sign numbers, but here we're also looking at fractions. To multiply fractions, we can check for cross-canceling, and then we will multiply the tops, multiply the bottoms. Will anything here cross-cancel? 5 goes into 15 3 times. We can divide both 6 and 16 by 2. 2 goes into 6 3 times. 2 goes into 16 8 times. We've cross-canceled everything we can cross-cancel, so that tells me that my answer should end up in lowest terms. Already, we've pre-reduced by cross-canceling. A negative times a negative is positive. Multiply the tops, multiply the bottoms. Double check, make sure it is in lowest terms, and it is. So our answer here, positive 8/9. Another thing we talk about when we're dealing with multiplication is factors of numbers. And look at number 30. It says find all integer factors of each number. Now your book has a discussion on finding these integer factors of numbers here at the top of page 68 under Objective 3. So be sure, if you haven't already, to look over that. A factor is a number that will evenly divide into a given number. And I think the easiest way to do this is start at 1. All numbers are divisible by 1. All numbers are divisible by themselves. So 1 and 36 are both factors of 36. In fact, that's a factor pair because they multiply together to give you 36. The easiest approach is to find all positive factor pairs of the given number. So let's just go down this left-hand column and say, 1 goes into 36 36 times. Does 2 go into 36? Yes. 2 will go into 36 18 times. Does 3 go into 36? Yes. 12 times. Does 4 go into 36? Yes. 9 times. Does 5 go into 36? No. Does 6 go into 36? Yes. 6 times. And I've repeated myself. Here at the bottom, I've repeated myself, so I'm done. If 7 or 8 or 10 or 11, if any of those had already been factors, we would have discovered them by now. So when you wrap around here at the bottom, you're done looking for those positive integer factors. Now I did say integer factors, that includes the negatives, so we also want to list -1, -2, -3, and so on. Now 6 is a repeated factor down here at the bottom. In my list of integer factors, I only need to include it once. So here are all of the integer factors of 36. I only need to include that 6 once. These are all of the integers that will evenly divide into 36. Now, having seen that, let's try another one. Number 32. They want me to do this same thing. Find all integer factors of 50. Let's start with 1 and the number itself. 1 and 50 are both factors of 50. Does 2 go into 50? Yes. 25 times. Does 3 go into 50? No. Does 4? No. Does 5 go into 50? Yes, 10 times. Does 6 divide evenly into 50? No. Does 7? No. What about 8? No. Neither does 9. Will 10 divide evenly into 50? Yes, but I've already discovered that. I've wrapped around at the bottom. So I'm done. If there had been any bigger factors of 50, I would have already found them. So we have these 6 positive factors. Let's list their negatives as well to get all integer factors. And that's all this is about. Now, this becomes particularly handy to be able to do when we get to chapter 5 and we're factoring polynomials. Being able to list all factor pairs of a given number will become a critical idea at that point. So understand this, get this down pat. Let's do a couple of division problems. Here in our homework set at the bottom of the page, let's look at number 38. Negative 28 divided by 7. Well, 28 divided by 7 is 4. A negative divided by a positive. Remember, the rules are the same for division as they are for multiplication. So we're dividing numbers of opposite sign. My answer will be negative. Number 46. In number 46, we're dividing fractions. You know the rule for dividing fractions. We flip and multiply, which is our definition of division from that blue box on page 68. We rewrite this as a multiplication problem, multiplying by the reciprocal of the divisor. You could just write 3 there, or 3 over 1. We check for cross-canceling. And in this particular problem, there's nothing that will cross-cancel. Remember, cross-canceling works only under multiplication. So don't check to cross-cancel while you're still under division. Wait until after it's a multiplication problem. Nothing will cross-cancel, so we multiply the tops, multiply the bottoms, and a negative times a negative is positive. When we talk about dividing real numbers, there is a division problem that we need to take a very close look at, and it's division by 0. You may have noticed in our blue box back on page 68, our definition of division. It said for any real numbers x and y where y is not 0. And that's very important. That implies that you cannot divide by 0. And does that make sense to us? Well, let's say that we have a problem like 10 divided by 5. 10 divided by 5 is 2. How do you know that? Because you first learn your multiplication tables, and now you're using them backwards. You know that 2 times 5 gives you 10, which tells you that 10 divided by 5 will be 2. If you have 0 divided by 5, you take 0 things, divide it into 5 piles. How many things are in each pile? 0. And that's because 0, this is representative of my answer here, 0 times 5 gives me back the original dividend 0. But if you take something and try to divide by 0, well, that's saying that whatever I get for an answer times, right, times the divisor, times 0, would have to give you the original dividend, 10. Now, I ask you this, what times 0 is going to give you 10? Anything times 0 is 0. There is nothing you can multiply times 0 to get 10. And so we say division by 0 is undefined. We don't even use an equal sign, because undefined is not a number. It is a word, it is a concept. And it says there is no way for us to define what the answer is going to be. Division by 0 is undefined. Blue box, top of page 70. It says for any real number x where x is not 0, the following hold. 0 divided by something other than 0. 0 divided by something is 0, while x over 0, something divided by 0, is undefined. So we need to keep that in mind. Remember, 0 in the numerator, never a problem. 0 in the denominator, can't do it. Undefined. While we're on this page, let's also mention these 2 brown boxes, equivalent forms. Based on our rules of division, when I divide 2 numbers of the same sign, the answer is positive. When I divide 2 numbers of opposite sign, the answer is negative. We can develop these rules that we have here called equivalent forms in the 2 brown boxes, middle of page 70. After looking at those, we can see that if we have a negative running around in a fraction, it can show up one of 3 places. It can be in the top, it can be in the bottom, or it can sit out front. Those all mean the same thing. Negative 2 divided by 3 same as 2 divided by negative 3, and they are both equal to negative 2/3. If I were to say, class, what is negative 2 divided by positive 3? You would answer me saying, that's negative 2/3. And the second brown box, this is just dividing two negatives. If you divide negative 4 divided by negative 5, two negatives make a positive when you're dividing, and 4 divided by 5 is what? 4/5. And so these are equivalent forms. Let's continue our look at the homework. And crank it up just a little bit. We now have an understanding of how to add, subtract, multiply, and divide signed numbers. We also know the order of operations. This is number 58. And without any coaching, I want you to try this one on your own. Go ahead and pause the video and then come back and we'll compare answers. Following the order of operations, we'll work in the parentheses first. 4 minus 7, or 4 plus negative 7 if you want to make 2 marks, gives me negative 3. And the only thing left to do is multiply. Negative 5 times negative 3. When you multiply, two negatives make a positive, and 5 times 3 is 15. How'd you do? Let's have a look at number 74. In number 74, we know that we work above and below the fraction bar separately. And the last thing we'll do here is divide as indicated by the fraction bar. So in the top, we multiply negative 40 times positive 3. A negative times a positive is negative. 40 times 3 is 120. In the bottom, negative 2 minus 3. You might do that in your head, or you might go ahead and make 2 marks. Change that to an addition problem. Negative 2 plus a negative 3. Either way, you get negative 5. And now dividing. A negative divided by a negative is positive. 120 divided by 5, 24. Positive 24. Let me show you something that happened in my head as I looked at this division. That cloud means that's me thinking. I'm thinking, you know, if I had 120 divided by 10, that would be 12. That's easy enough. Well, then what would 120 divided by 5 be? If 10 goes into 120 12 times, 5 would go in twice as much, or 24. If that works for you, use it. If not, you can always drop back to long division. Either way, as long as we get that positive 24. All right, here's another one I want you to try, working ahead of me. Number 78. Number 78 is a busy little problem. We just take it a piece at a time. Again, go ahead and pause the video and come back and we'll compare answers. Again, we have a fraction bar. We work above and below that fraction bar separately until we're ready to finally perform the division indicated by that fraction bar. In the top, we'll do the powers first. We can do both of those powers in the same step. 5 squared. 5 times 5 is 25. Minus 7 squared. 7 times 7, 49. Over. We jump to the bottom. In the denominator, we'll deal with what's in parentheses first. 3 plus 3 is 6. Back to the top. 25 minus 49. I can make 2 marks here, but I mean, think about it. Isn't that just going to be the same as 49 minus 25, but negative, because we're subtracting off the bigger number? 49 minus 25 leaves me 24, but it will be a negative 24 because the larger number had the negative sign. Same thing as if we'd made 2 marks. We would subtract big minus little and give the answer the sign of the larger absolute value. 49 is bigger, it was negative, and so the result is negative. Over in the bottom, 2 times 6 is 12. We boiled down the top, we simplified the bottom. We're ready to perform the division. You divide 2 numbers of opposite sign, a negative divided by a positive is negative, and 24 divided by 12 is 2. How'd you do on that one? Once again in this section, just like in the previous, we had a couple of charts that indicated words and phrases indicating addition and subtraction. If you look on page 72, we have a couple of charts. The chart at the top indicates words and phrases having to do with multiplication. The chart at the bottom, words and phrases having to do with division. Again, if you have not looked over those yet, be sure and do that, because now we're going to be translating. Back to the homework. Looking at the problems number 85 through 96, I think you can handle those. You're just plugging in and following the order of operations to crank out an answer. So I'm going to bring us down to number 100 for our next example. In this problem, we are asked to translate. We are to write a numerical expression for the phrase and then simplify. Number 100. Twice the product of negative 8 and 2 subtracted from negative 1. Piece at a time. Take it in small little pieces. Twice. Twice means 2 times something. 2 times what? The product. Twice the product. So what am I multiplying 2 times? 2 times some multiplication, some product. The product of what? Negative 8 and positive 2. That and is your multiplication dot. The product of negative 8 and 2. So far we've written twice, 2 times. Twice the product of negative 8 and 2. It says now comma, meaning all of that now, subtracted from. Subtracted from. Where does my minus sign go? I'm subtracting whatever this turns out to be from something in front of it. This whole thing subtracted from negative 1. So there we are translated. We've changed our word phrase into a numeric expression. They also asked us to simplify. So, working in the parentheses, negative 8 times positive 2 is negative 16. Got ahead of myself. We're now doing the multiplication here. 2 times negative 16. Notice I've already copied my subtraction sign down to the next line. And I'm now multiplying simply this 2, this positive 2, times that negative 16, which is going to give me a negative 32. So we're subtracting a negative 32, which is what? The same as adding a positive 32. Negative 1 plus 32, well, that's the same as just 32 minus 1, 31. Let's try another one of these. Number 106. Number 106 says the quotient of negative 20 and the sum of negative 8 and negative 2. Take it a piece at a time. The quotient of, quotient indicates division. In algebra, division is typically a fraction bar. The quotient of what? This and that. The quotient of negative 20 and the sum. The quotient of negative 20 and the sum. The sum of what? The sum of negative 8 and negative 2. Okay, look at this again. The quotient, that's our fraction bar. The quotient of this and that. That first and is this fraction bar. What are we taking the quotient of? The negative 20 and some sum. What sum? The sum of this and that. That last and is your plus sign. The sum of negative 8 and negative 2. So there's my expression algebraically. And we want to simplify. Working in the bottom, negative 8 plus negative 2 is negative 10. And now dividing, a negative divided by a negative is positive. 20 divided by 10 is 2. Let's try number 108. Number 108. The sum of negative 18 and negative 6, comma, divided by the product of 2 and negative 4. Take it a piece at a time. The sum, all right? I got that part. The sum. The sum of what? Negative 18 and negative 6, comma, meaning that whole thing is now what? Divided by. The whole thing divided by. Divided by what? The product of. The product of what? 2 and negative 4. I don't have to have the dot there. I used that as I was taking that a piece at a time. I wanted to write divided by the product. Take it or leave it. The parentheses will serve to show the multiplication if the dot's not there. And crank this out. Working in the top, negative 18 plus negative 6 gives me negative 24. In the bottom, 2 times negative 4 is negative 8. And negative 24 divided by negative 8, positive 3. I'm going to get you started on number 114. I'm going to leave it to you to finish the problem. So let's look at number 114. The sum of 3/4 and 1/2, comma, times the difference of 2/3 and 1/6. Little bite-sized pieces. The sum. Let's write the sum. The sum of what? 3/4 and 1/2. Comma. Meaning that whole thing now times this whole thing now times what? Times the difference. Times some difference. The difference of what? Or I might say the difference between. The difference of, or the difference between 2/3 and 1/6. So there's our translation. Now, I want you to finish the problem. I will go ahead and tell you that the answer is 5/8 Make sure that you can simplify that and arrive at 5/8. Now, notice your homework includes 129 through 136, all of those. I want you to pay careful attention to those problems. Those problems include our rules of divisibility. And on your homework sheet, notice that it says, learn the rules from those problems. Those will be important to us down the road. So that's what I've got to say about this section. I'll let you get started on your homework.